Okay, this is chapter 7.6, Finding Dimensions of Prisms. I wanted to talk real quick about what we've discussed in the past, and you guys have heard this before, that you have a distance from point A to point B, and that distance, is a straight line, usually. And we can do curves, but we're doing straight lines today. And you might say, oh, well, this is 3 feet. It's something you can measure. We start doing other shapes, rectangles and stuff. We get into perimeter, and we have to measure around. Or we get into area, and we have to measure the inside. And this is not a great rectangle, but it represents a rectangle that is 3 feet by 3 feet. I probably should have done 4 feet on this one edge, but it doesn't really matter. What we can see is that if this is 3 feet and this is 3 feet, our inside, we count up the squares, is 9. And the area equals length times width, which is 9 feet to the second power. But today we're kind of talking about volume. Volume ends up being similar, but it ends up being length times width times height. And the book, your textbook, page 314, which this is a little picture from, gives us kind of an example of what to look like. Instead of being flat, each of these squares turns into a little cube. And so we have a length, we have three-directional length, a width, and a height, and we have to measure in all three directions. So first of all, we just had distance. This is one direction, and the answer, the distance is just 3 feet. When we start working on area, we have two directions, length and width, and we get 3 feet to the second power, and we say squared because we're measuring in two directions. When we start doing volume, we have length times width times height, and we have three directions, so the units end up being to the third power, and we often call that cubed. So instead of feet to the second power or squared, it's going to be feet or inches or centimeters to the third power or cubed. And you can see what it looks like here. How many cubes do you need to fill the box? Well, you've got one layer on the bottom, and the bottom layer has 12. It's 4 times 3. But there's a second layer, and so there's another 12. So really what you end up doing is multiplying, not by 3. You've got 4 cubes wide by 3 cubes long, or the other length and width, and you have 2 stacks of them, and this is multiplying by the height. You have one whole stack here, and when you add a second one, you multiply by 2, and so there's 12 on the bottom, and there would be 24 altogether, and so the feet would be 24 feet cubed to the third power. Now, I don't know that this is feet. It might be. It's just 12 cubes. But, if each cube is 1 foot by 1 foot by 1 foot, like this one over here, then that's kind of how that works. So find the number of cubes it takes to fill a box. So the top layer is 1, 2, 3, 4, 5 by 1, 2, 3. It's 5 by 3. But the height is by 2. And then when you multiply that all together, you can do 5 times 3 is 15, times 2 is 30, or you could actually switch these and do 5 times 2 is 10, and then multiply that by 3, and you still get 30. And it's 30 units cubed. And here you have 3 by 3 by 3. So the area, sorry, not the area, it's the volume. The volume equals length times width times height equals 3 times 3 times 3 equals 27 units, and you can just use a U, to the third power, units cubed. And that's just basically how that works. These are called prisms, and it's a rectangular prism. A prism is anything that has length. This is just a well, let's get a new page. This is just a square, but if I add length to it, this isn't going to be pretty. If I add length to it, it becomes a prism. And this is a rectangular prism. So you get a rectangle on the bottom or a square on the bottom, and then you make it tall, or you stretch it out along this direction, and it becomes a prism. If you were to do, say, the same thing with a triangular shape, and you were to stretch it long, then what you'd create would be a triangular prism. So this idea of stretching the length is what makes a prism. You could have an octagonal prism or a pentagonal prism, which would be sort of a five-sided figure that you stretch out long, and it becomes the end shape is it's the first word, octagon, and then because it's a prism, it's stretched out long, and you call it that. So we have rectangular prisms today, and you're just finding volume of those, and you simply just have to remember the formula: volume equals length times width times height. And then when you find a shape, check out the dimensions. Might have 7 meters by 4 meters by 5 meters. And you just replace those. Length is 7, width is 4, and height is 5, not h. And then you multiply. Not w, boy, I did it twice. 4 and 5, length, width, and height. And then you can multiply this. 7 times 4 is 28. And 4 times 5, 28 times 5 is something. I could figure it out, but I might prefer to do 4 times 5 is 20, and then 20 times 7 is 14, so it would be 140 meters to the third power. That's how this works. That's what the volume is equal to. Now, sometimes that might give you a volume and miss a dimension, and that's another important thing that you might need to use. They might say that you have this box, and this is using the strategy that we've been learning this chapter, and this box is 8 yards tall and 8 yards wide, but it's, I don't know how yards deep. And it might say that the volume let me figure out what the volume is. I made up a problem and I don't know the answer. Well, I guess we'll use something easy. The volume is equal to 640. Okay, and they want us to figure out what x is. So we start with our volume formula. Volume equals length times width times height, and we plug in the things that we know. And this time we know the volume. It's 640, and we don't know the length, but we do know the width and the height. So it would be 8 times x, or it might be better to use the letter that stands for the L, but it starts looking like a 1, and I worry that you guys will get confused. This is an L. 8 times length. And so then we'd simplify just a little bit by multiplying our two 8s to get 64. And then we have to divide by 64 on both sides. And then this 64 cancels out, so that h is equal to 640 over 64, and most of you guys will figure out right away that that's 10. If you multiply 64 times 10, you get 640. And so the h is 10. I suppose we could say feet or units, and that's how you do it. So you've got to be able to do it both ways, and it should be a pretty easy assignment if you understand how to solve if you're given 2 of them but not the third, or 3 of them but not the fourth. And we'll just use this method we've been doing for the last week or two. Good luck.